Saving flags on a stack. I already showed you the two instructions: push flags double word and pop flags double word if you like. But there is something else I'd like to note about flags register, is that there is no mnemonic that would allow us to move the flags. For instance, we could use register EAX, and there's no mnemonic for flags, so there's no mnemonic such as EFL, for example. Okay, so or E flags, none of this will compile. So if you try to build this, it's just going to say undefined symbol. It just doesn't understand. But if you want to take your flags and save it in the register, typically what you do is just this: push FD, which is instruction without operands. You can use stack, and then pop wherever you want to save it. Right, so here we can add comments, basically specifying that you know, just say that EAX equals E flags, right? So we can do it this way: push flags and then pop wherever we want this to be now set. So the stack can be used in exchange like this. And also there is also load AHF. LAHF and save AHF will load and save lowest portion, the lowest half of actually the lowest 8-bit of the flag register, and load them into register AH. But we've talked about these instructions when we were talking about moving things in memory and between memory and stack. All right, so this is regarding the flags. So we have this, we can say here it's a technique to set flags, to set a register equal flags. So instead of move instruction, we can use push and pop. Okay. Okay, so the next thing, what else is available, is that again the instructions, there are two sets of instructions that can save all 32-bit instructions, 32-bit registers and 16-bit registers. So there are these instructions that we typically use in 32-bit mode is push all double word registers and pop all double word registers. The corresponding 16-bit commands are push A and push A and pop A. So so right here, if you'd like to save all the registers, you know, we don't really have to do this in our code. This is not really necessary. It's just an idea that you can preserve all registers at once, but it's important to know in what order they are saved. So right here, if we use instruction push AD, this is the order in which they're saved. The first is EAX, then CX, DX, BX, and so forth. So it also saves stack pointer itself and base pointer as well. So this is how all general purpose registers are pushed into the stack. And when popped, of course, it's exactly the opposite order of this order, because remember, all push and all pop should be matching in terms of the numbers, but they all have to be also matching like this, right? So this is trivial push pop instantly, but here is a little bit farther away, and this is even more apart, and this is another one. But if you look at all of my push and pop, they match exactly like this. You just cannot twist them. I mean, you can pop into whatever you want, but each push has to have a corresponding pop, and the order is also very important. And finally, the first one was EBP, and of course I pop it right before before I return. And that's how I can return. If I forgot or mismatched any of the push and pop, this will be a little bit disastrous. I mean, this is just gonna lead to really bad consequences. And so anyway, so these instructions: push all double word registers and pop all double word registers, allow you to avoid those little, tedious push EAX, ECX, EDX individual instructions. And they're also, by using the single push AD or pop AD and the corresponding pop AD, should I say, allows us to make the program run faster. So using a single command is just faster than using individual commands. It's going to take less CPU cycles to execute. So these are the ideas of how you can save and restore all general purpose registers. Again, why would you do this? Well, because there's very limited number of these registers, and sometimes you need to load them with all sorts of addresses in memory and values that use in computation. So you run out of these registers, and your choice is then to preserve them and use them again. But in this case, most likely you would find these instructions, push AD and pop AD, at the beginning of the procedure and at the ending of the procedure, because inside the procedure you're using all of the registers, so there's no reason to hesitate to save all of the registers on the stack and be able to restore them, so that the caller doesn't have to worry about registers to change, and it's going to be easy to make a call into your procedure if you preserve all of your registers and restore them, so that the caller doesn't see any differences, but you can then use them all in your own code inside your procedure.